Let us perform an activity to observe the diffusion of particles of liquids. Click each tab to know more. Take 2 beakers, fill them with water. Now take potassium permanganate. Add some crystals of potassium permanganate in a beaker. Take a dropper. Now add a drop of potassium permanganate solution slowly along the side of the other beaker. Observe the changes. In this activity, we observe that the particles of potassium permanganate and water spread and mix up with each other on their own. Finally, we learned that the particles of potassium permanganate and water move. Therefore, we can conclude that liquids also diffuse with each other like gases. Let us know about the diffusion of solids, liquids and gases. We know that solids and liquids diffuse into liquids and gases diffuse into gases. Certain gases from atmosphere, particularly oxygen and carbon dioxide, diffuse and dissolve in water and support the survival of aquatic animals and plants. Diffusion, therefore, is a very important process for living things. Oxygen diffuses from lungs into blood. Carbon dioxide diffuses from blood into lungs. Solids, liquids and gases diffuse into liquids, and rate of diffusion of gases is higher than that of liquids or solids. Let us do a lab activity to observe the speed of diffusion of 2 gases. Click each tab to know more. The aim of this activity is to observe the speed of diffusion of 2 gases. The materials used in this lab activity are glass tube, rubber bung, ammonium solution, hydrochloric acid, pieces of cotton. Take 2 pieces of cotton wool. Soak 1 cotton piece in ammonia solution and the other piece in hydrochloric acid. Take a narrow glass tube. Insert both cotton pieces separately at the 2 ends of the glass tube. Now close the both ends with rubber bung. Observe the changes. In this activity, we observe the formation of a white ring from the least distance of piece of cotton with HCl solution. Because the hydrochloric acid gives off hydrogen chloride gas and ammonia solution gives off ammonia gas. Thus, we learned that the both gases react together to form a white substance called ammonium chloride. Therefore, we can conclude that HCl is more dense than NH3 because NH3 travels a farther distance than the HCl in the same period of time.
Knowledge check. Attempt the following questions to check your understanding.
Can matter change its state? We all know from our observation that water exists in the three states of matter: solids as ice, liquids as the water, and gases as water vapor. We must have seen many other materials that can exist in different states. For example, coconut oil is usually liquid in state, but if the weather is too cold, it becomes solid. Similarly, camphor is a solid, but if we leave it in the open air for some time, it changes to gas. Solids, liquids, and gases are the different states of matter, but the properties of matter are different in different states. This is because all matter is made up of very tiny particles. Let us do some activities to know about these particles and their arrangement in their various forms. Here, let us perform an activity to know how small are the particles of a matter are. Click each tab to know more. Take a beaker. Fill it with water. Now take potassium permanganate. Add some crystals of potassium permanganate in a beaker. Now, take out approximately 10 ml of this solution and add it to 90 ml of clear water in another beaker. Once again, take out 10 ml of this solution and add to another 90 ml of clear water. Carry out this process 3 or 4 times and observe changes in the color of the solution. We observe that the solution remains colored even when highly diluted, but the color of the solutions decreases with dilution. Finally, we conclude that there must be several tiny particles in just one crystal of potassium permanganate which get uniformly distributed in water to change its color. Now, let us perform an activity to understand the force of attraction between the particles of the matter. Click each tab to know more. Take a beaker. Fill it with water. Mark the water level. Add some salt to the water. Stir it thoroughly with a spoon. Observe the changes. Once again, add some more salt to the water and stir it. Now, observe the changes. Here, we find the changes in the levels of water. Open a water tap. Allow the water to reach the ground. Now try to break the stream of water with finger. Release the finger after few minutes. Observe the changes. Here, we observe that the water flows with more velocity than its normal velocity for few seconds after the finger is released. Later on, the water reaches its normal velocity. Similarly, we observe that the forces of attraction between particles are the maximum in solids, intermediate in liquids, and minimum in gases. Finally, we learn that both solid and liquid particles have some space between them. The solid particles enter in the space between the liquid particles when solids dissolve in liquids. We also learn that the particles of the matter have forces acting between them that keeps the particles together. It is also clear that this force is not equally strong in all the forms of matter. The force between particles of matter is called as cohesive force. Diffusion of matter. The intermixing of particles of two or more different substances on their own is called diffusion. In the incense stick activity, the particles responsible for scent move and enter the space between the air particles. The scent particles quickly spread across the room. The rate of diffusion of gases is very high because the particles of gases travel with high speed. Rate of diffusion of gases is higher than the liquids, while the rate of diffusion of liquids is higher than solids. There are two reasons for the higher rate of diffusion of gases. One is due to the higher speed of gas particles and another due to the greater space between them. Similarly, the liquids have greater diffusion rate than solids because particles in liquids move freely and have greater space between them when compared to particles of solids. The screen shows the difference in arrangement of particles in solids, liquids and gases. The diffusion of solid into another solid substance is negligible due to the immobility of particles in solids. The diffusion of a liquid into another liquid and that of a solid into a liquid is much slower than the diffusion of gas into another gas. The following table shows the comparison of the properties of solids, liquids and gases.
Knowledge check. Attempt the following questions to check your understanding.